Hey guys, welcome to question MM388 of the Maths Methods Fortify study guide. So, this is quite a tricky question, so if you couldn't get it, it's all good. We're dealing with conditional probability here. So there are two red bracelets and X green bracelets in a jewelry box. Two bracelets are taken from the box without replacement. If the probability of taking at least one red bracelet is equal to 11 on 21, the value of X is. Awesome. So we're basically looking for the amount of green bracelets that are in the box, right? But we're still not going to be able to do this without just trying to create a tree diagram for ourselves. So, as always, with these kind of questions, we have two possibilities to begin with when we first take out a bracelet, right? We can either take a red or a green. Yep, so red and green. Again, the second bracelet that we take out could either be red or green. Sweet. So, let's figure out the probability of each one of these things happening. So, if we have a if we put our hand into the box, is it a box? Yeah. If we put our hand into the box, the chance that we pull out a red bracelet is equal to the amount of red bracelets divided by the total bracelets that we have, right? So the amount of red bracelets we have is 2, but how many total bracelets do we have? We don't know how many green we have, so it's hard to know how many total we have, or it's impossible to know exactly how many total we have. So all we can say is that our total is equal to this plus this, right? 2 plus x. So we know that we have 2 red, and we know that we have x green, so our probability of picking out a red is 2 over 2 plus x, so red plus green. If our x was 3, then this would be 2 over 5, which would make sense, right? Now, same again with the green. So how many green do we have? X. So we have x divided by our total, which again is 2 plus x. Awesome. Now is where it gets even a little bit more tricky, okay? So here, we've already taken out a red, and we're looking for the probability that we take out another red, right? So here, we've already taken out a red, which means there's 1 red left, which means we have 1 over the total number of bracelets. Okay, so we've taken out 1 red, so there's 1 red and x green, which means our total bracelets is 1 plus x. Awesome. Now, for our green, here we've taken out a red, and we are now taking out a green. So how many greens are left? Well, we haven't taken out a green yet, so we still have x number of greens left, and our total is, again, 1 plus x, because we've taken out a red. Now, once we've taken out a green, we need to check out how many reds we have left, or what the probability of taking a red out. So we've taken out a green, which means there's still 2 reds left. So we have 2 over our total number of bracelets, which is still 1 plus x in this kind of row, because here we've taken out a green, which lowers our total by 1. Our next bit here is green again. So we've taken out a green one, and we need to figure out how many greens are left. Well, if we started with x greens and we've taken 1 out, that means we're left with x minus 1 greens. Okay, so if we started with 4, we would have 4 to begin with, then we've taken 1 off, so we end up with 3. That's how that works there. By this time, we've already taken out 1 of these bracelets, which means that our total again is 1 plus x. Now, I know this is a bit tricky, but this is where our key comes in, okay? So it tells us that the probability that we pick out at least 1 red bracelet is equal to 11 on 21, okay? So that means that the probability that we pick out at least 1 red is equal to 1 minus the probability that we pick out both greens, okay? Because in every single one of the, we could just add this path, and this path, but it's quicker to say, well, the total of this is 1, and we know that if we're taking at least 1 red, we're dealing with all of these probabilities here, except for this last path with both greens. So what we're going to do is we're going to take this whole probability, and we're going to minus the probability of this path, and that's going to leave the rest left over. So that's exactly what we're going to do. So we're going to say that the probability, can we still see this? Just the probability of less than or equal to 1, sorry, at least 1 red is equal to 1 minus this path here, green, which is x over 2 plus x multiplied by x minus 1 over 1 plus x. Awesome. This is the formula that's going to help us solve this. So I'm just going to rub this out. Sorry, I should have said that first. Just rewind and pause it if you need to have a check out of that. tree diagram. But we also know that the probability of this happening is 11 on 21, right? Because the question told us that. So 11 on 21 equals 1 minus x over 2 plus x multiplied by x take 1 over 1 plus x, right? So now we've only got one variable. We've got our x and nothing else, right? Which means we're actually going to be able to solve for x. So I would just now sub this into my calculator, because remember that x represents the number of green bracelets that we have, okay? So as soon as we solve for x, we'll get the number of greens that we have. So if you put this into your calculator and solve for x, what you're going to get is x equals negative 4 on 11 and x equals 5. Now, x cannot be either a negative or a fraction because we're dealing with numbers of bracelets. So it has to be a whole positive number, can't have a negative number of bracelets. So therefore, this cannot be equal to negative 4 on 11. So therefore, x equals 5, which is our C value. Guys, if you had any troubles with this, please hit me up in the comments below. But that's the final answer for MM388. Thank you very much for watching, and I will see you in the next video.